It is likely that some parts of the Hyperloop will be constructed underground. After this lecture, you will be able to explain why this is favorable and what the challenges are of constructing underground Hyperloop. First of all, let's have a look at the reasons why the infrastructure of Hyperloop should be built underground. These reasons are primarily environmental conditions, urban planning, and landscape pollution, but moreover also the structural benefits. First, the environmental conditions. When constructed above ground, the Hyperloop tube will be exposed to sunlight. The tube will therefore increase in temperature, after which the tube wants to expand. This is called thermal expansion. At some points, these thermal strains are prohibited, and as a result, compressive stresses will arise in the tube. When these compressive stresses are becoming too large, there's a chance of buckling of the entire structure. A solution to this might be the use of dilation segments, which allows for the tube to expand freely. The downside, however, of these dilation segments is their risk for bad air tightness. More vacuum pumps will therefore be needed to overcome leakage of air into the tube. Another environmental issue is that most hubs are located near the coast. The air will contain saline water, which has the potential to corrode parts of the structure. This asks for intensified and costly maintenance. The most important consideration in the construction of underground Hyperloop infrastructure is, however, that in densely populated areas, it is extremely difficult to construct Hyperloop tubes above ground. In order to accommodate comfortable travel for passengers, the radii of the bends in the Hyperloop infrastructure should be immense. This makes it nearly impossible to fit the infrastructure within the current urban planning and housing. Moreover, the construction of tubes above ground will inevitably lead to landscape pollution. Potentially, the tubes will also form a social barrier, as line infrastructure may lead to social segregation, literally creating physical borders between people. All of these phenomena are unwanted in modern-day society. Lastly, underground infrastructure is desirable in earthquake-prone areas. Underground infrastructure consists of segments which form a relatively flexible structure. During earthquakes, the tunnel will move with the soil surrounding it, therefore preventing damage to the structure. This is not the case for above-ground infrastructure, where the entire structure will start to move and perhaps collapse. The largest downside of underground infrastructure is, however, that the construction costs are higher. This as the rate of construction is lower and accessibility is more difficult. In addition to that, an additional investment needs to be made into the purchase of a specialized tunneling machine. As a result, additional methods are needed to make the underground construction of Hyperloop more profitable. Key to this is including other utilities into the infrastructure of Hyperloop. This way, additional earnings can be created, resulting in profitable underground Hyperloop infrastructure. An example of such a utility that can be included are electricity and internet cables that are located at the top of the tunnel. Using cable trays, the cables itself can be installed and maintained easily. The vacuum tubes of Hyperloop are spaced in such a way that personnel can perform maintenance on these cables and the tubes, while inside the vacuum tubes, the pods still continue to travel. Including internet cables provides a good way of connecting the larger hubs between which there is a lot of data traffic. Concerning the electricity cables, sustainable energy, which is usually generated in less densely populated areas, can be transported between the larger hubs of Europe. This while considerably reducing the cost of the construction of these high-power cables, as use can be made of the Hyperloop tunnel. Additional space can be used for sewage, transport of drinking water, or for the storage of excess rainwater. Potentially, this space could also be used for other types of transportation. For example, within a city, it might be beneficial to use the space as a small transport way for goods through the cities. Another challenge that must be overcome is the longer construction time of underground infrastructure. At this moment, underground tunnels are built at a rate of around 15 meters per day when using a tunnel boring machine. When partially building the Hyperloop network underground, the construction rate must go up. Otherwise, it will simply take too long to build a Hyperloop network. Several initiatives have, however, been started worldwide to increase the advance rates of tunneling machines. The best known example of this is the Boring Company, which is an initiative by Elon Musk, who also introduced Hyperloop. The objective of this Boring Company is to increase tunneling speed to over 100 meters per day. This concludes the lecture on infrastructure design of Hyperloop, in which you have learned the potential reasons, the advantages and disadvantages of an underground network.